Alright guys, welcome to my video on JWT and Actix Web. So in this video, we're going to take a look at my implementation of JWT in SyntaxMakers, the job hunting website that I'm working on as a side project. And before we get started, just to make sure we're all on the same page, I'm going to explain how CORS works, because in order to make JWT work, we need to set this up properly. So as you can see here, we have our HTTP Actix web server instance, and then we have a wrap call, which is enabling the CORS middleware to be available in the service. And what we're doing here is we are allowing, via the usage of CORS, to let other websites call into our API service even if they're not on the same URL. So what that means is my client-side React application, which I built with Vite, is running on this development URL, 5173, right? My API service is running on it is running on localhost, but it's running on port 4003, so it's considered a different website. So the core system will allow you to control what other origins, meaning callers into the API service, so what other origins have access into your service. So this first line is enabling our testing client-side app to have access to our API. So then the next thing after that is we can control the HTTP verbs that are passable to our API. So we have only get and post. So that would mean that put and delete and whatever the other ones are not available. So they will be rejected if anybody attempts to make those verb calls. And then certain headers that we need are also being allowed. So content type for like JSON and stuff. And then we need the authorization, because we're going to be passing back that token as a bearer token to our calls from the client side in order to authenticate. And then finally, the super important call right here, which is saying that I am allowing, that is, this API service is allowing cookies and credential information to be passed into me, right? And then on the client side, just so you can kind of match the two up, on the client side, whatever the call is that you're making, right? So I'm making a fetch call. You need to include those credentials from the client side. All right, so that was a quick overview of CORS, and let's start explaining the actual JWT aspects of the application. So if we start from the top, the way that it works is it will create a token of this type called claims, and the standard has a bunch more fields than just these two. I think there's something like 8 or so different fields that you could use, but I only needed these two. So what I'm going to do is I'm putting the username as the subject. That's what this shortcut stands for. And then I'm going to give a specific expiration listed as seconds. And then that's the payload data that's going to be in the actual token once it gets created. So then the other thing that we need to know, at least as far as our app is concerned, is that we need to be able to create these tokens by encoding them so we can pass them to the user. And then we need to be able also to decode the tokens so that we can actually read them back, because when they are encoded, they are not in a readable state. So this auth keys type is going to be shared in the global state of the application. If you're new to Actix Web, then check out the links in the description. I'll have links for my videos on Actix Web and some of the other related information that you'll see in this video. But you can see that the auth keys is set up in here so that it can be shared later by any of the route handlers that are in the app. So that's why we need this. And then this is the function that you were just seeing there that is setting these auth keys. And let's explain how these auth keys are set and the mechanics of encoding, decoding. So then I am using the encryption format called ED25519. I'm just using this because this is one of the more secure and more popular formats that are out there. So what I'm doing here is I'm generating a key pair, and I'm using a random seed to do that. And then I'm putting this as the output is a serialized version of that key pair. So that's what this is. And then next, based upon that key pair, I'm able to generate an encoding key. And then what an encoding key is doing is it's trying to generate a hashing signature of the unique data that we have here. So an instance of this struct claims is of course going to have a specific username, let's say Dave, and then a specific expiration, right? So that's the data of our token. So then when it gets encoded, it's going to generate a unique hash that acts as a unique identifier that is not reproducible for this specific data instance. So then if somebody were to hack that token, change the data that is in there, right? Maybe impersonate somebody else or try and lengthen the expiration or whatever the case may be, the data will not match the hash, and therefore we will detect it, the hash, and we'll detect it, and we'll reject that call, right? So that's what this is about. So then here we are doing the reverse. We are generating the capability to decode that token. So we need the real pair, not just the serialized document, but the real pair. And we need to get the public key from it so we can generate the decoder key because it works off of the public key. And then we return those two keys. Okay. Now the mechanics of this is a little bit involved, and I didn't want to, be writing this stuff multiple times within the application. So I have some utility helper functions here. The encoder is also returning the token itself, so that's why it's called get token. And then decode token is obviously decoding the token. So what we're doing is, again, that username will be the subject, and we're generating an expiration. So we're passing in that encoding key, selecting an expiration in seconds. It's optional, so if I don't select it, I just use the default. Otherwise, I use it. And then I create that claim object. Let's close this. I create that claim object, and it only has the two fields in it. And then I encode a new token. So that encoding is done with the EDSA, which is equivalent to this. And then the claims, so this is the data, right? And then this is the encoding key. And then we have our token. And it's in string format, and that's what I return whenever somebody requests a new token. So then we need to decode the token because we need to verify the token. So we take that token, we take the decoding key, and we show what type of encoding was used to create the token. So again, it's the EDSA style, and then we're going to decode it. And we're going to generate a decoded object, which gives us access to the claims, which I turbo fished in here as our claims type, right? So this is the underlying mechanics of doing the encoding, decoding, token generation, encryption, hashing, all that stuff, right? So then we need to be able to actually process the authentication. So things like logging in, things like verifying to a secured API URL. You know, does this guy have an authenticated token such that he can access this resource, right? So now we need to build all of that stuff out. So part of that would be the actual call to the database to make sure that the username or email or whatever the mechanism to identify the user is that you're using on your website, and then the password that they give is correct within the database itself, right? So obviously we need to do that. So I am handling that within the common repository user folder repo authenticate function, right? So it's going to access the database and it's going to ask, hey, does this guy with this email and this password even exist? So straight off the bat, we need to take care of that. And that's why I'm showing you this, right? So then back to the JWT stuff. So then once that piece is taken care of, we can do the actual work related to the token stuff, right? So in my case, I put that into a function called login. Obviously, the user is trying to log in. So my function is called login. So this is the route handler that the user is using. So server source routes, authentication, routes.rs. And all of this code is open source. I'm going to provide a link in the description. So don't worry about, all the specific details. It's going to be in there. This syntax is trait bounds. So it just means that I want certain types in here to be constrained to certain traits. If you have no idea what I'm talking about, I have some videos related to this sort of information. Again, I'll leave a link in the description. So let's just move on. So then I have the app data. Again, I need the encode and decode tokens, right? So then I have login credentials. So the email, the password, and then also the type of user, developer, employer, that sort of a thing. And then here is our authenticate function itself, right? So going to the database, does this email exist? Does this password match the email? All of that stuff. So assuming that initial important function is executed properly and succeeds, then I'm able to jump to this portion of the code, right? So this is a result, so I need to make sure it's successful. If it is successful, I need to make sure that the success is of the authenticated successfully variety, right? And I also have a payload of ID in here as well. And then I use that ID to get the actual developer object because I need the username in order to create the token, right? Now you can feel free to use email if you want to use email, but you need some way of identifying the user in the token without including, password information or anything like that, because the tokens can be hacked. So don't do anything like that. But you can pick an email, you can pick a username, you can even pick, if you use UUIDs, you can put that in there as the identifier. But I chose username, so I need to grab that username. This call is failable, nullable, so I have some checks in here for obvious reasons. So if it is successful and it is not null or not empty, or I guess in Rust lang it's none, right? So if it's successful, I grab it, I get the username, right? I pass it into the get token as well as all the other required parameters. So this is my expiration of the token. This is the encoding key. And then I get my token, right? Now, okay, but why do I have two tokens, right? Well, so JWT is super popular, but it is not super secure. So in reality, something like server-side sessions, everything contained on the server side is probably more secure, but JWT in some cases you just have to use it because that's what the vendor uses, and also it's like super popular. So what I am doing is what you would call best practices type activity. So I'm going to explain that right here. So we have two tokens and they're all going to the user. And the way that the mechanics of this works is that we have a token that we generate only for the purpose of asking for new tokens. Okay, I know that sounds weird, but let me explain that. So I get a refresh token, and this identifies, or the user gets a refresh token, and it identifies them as authenticated and valid on the service, right? I pass a cookie that contains that refresh token, but for security purposes, I only make that cookie accessible in HTTP. Or said another way, what that means is JavaScript cannot access that token at all. Okay? So then that means that a whole host of cross-site scripting attacks, JavaScript related hacking attempts aren't really possible because this cookie simply cannot be accessed by JavaScript. So that makes the refresh token as an object itself much more secure. Okay, so then where does access token come into all of this? So as I said, refresh token is not what we're using to authenticate. It is not checked to authenticate the user. Only the access token is used to authenticate the user. So what we do, so this is a bit of a trick, but it is a best practices trick, is we give a very, very short time to live, a very short expiration to our access token. I put 10 minutes for testing purposes. Don't put 10 minutes. Put 2 minutes, 1 minute, whatever makes sense. Just be aware, the shorter the expiration time, the more load on your server. Okay, so just try to balance that out, but around 2 minutes is probably ideal. And what will happen is you send this access token along with the refresh cookie to the user, but you send the access token as a payload in the body of the response, right? And therefore, the user now, the user's JavaScript, in this case, again, I have a React application, will have access to the token, and therefore they can pass the token, not here, where is it? Yeah, they can pass the token in the authorization header as a part of the bearer. Okay, and the reason for that is because that is what is expected on the server side in order to do the authentication. So what this means is I want to get a developer by their email. So I make a fetch network request to my API service, right? But my API service has secured this call. It's not open to just anybody to make. So you need to have logged into the system first in order to be able to make that call. So that means that you need to have received an access token, right? Assuming this login is successful, right? So assuming the login is successful, you have received the access token, and then you're able to pass that access token in to the authorization header. And then when the API service receives it, and I'll show you all of this code in a moment, but once the API service receives it, it's going to decode that cookie, verify that cookie, make sure everything is correct on that cookie. Now, then you might ask, okay, well, what is this then? Why am I having this? This JavaScript accessible token is less secure, significantly less secure than an HTTP non-JavaScript accessible token, cookie, whatever you want to call it, right? Because again, if the client machine has been hacked, it's possible that JavaScript, malicious JavaScript is there, which means that it will have access to the token, being able to either modify the token or maybe even copy and steal the token, right? So this access token is less secure. However, we need the access token in order to pass it from our fetch call to any secured API URL. So it's a little bit of a catch-22. So the way this mechanism works is by having a very short access token lifetime, again, ideally around 1 or 2 minutes, we are able to make the window of hacking or a hacker coming in and doing something very small. And then when the token expires, you don't want your user to be re-logging in or having to re-log in every 2 minutes. That would be horrible, right? So we have this refresh token that is never used for checking authentication. It's only used on a subsequent call, and you can automate this behind the scenes so the user doesn't have to even know, right? But every 2 minutes or whatever the expiration is, on the client side, you would have a request using the refresh token. Hey, I'm authenticated. I'm who I say I am. Give me a new access token, which again is 1 or 2 minutes long. In this case, for testing, I have 10 minutes, right? So then if a hacker manages to get in, they have such a small time window of being able to do their thing, such that if that time window expires, even if they try to use that stale access token, it's not going to work, because during validation, we know it's expired and we're not going to accept it. Okay, I know this was a lot. Maybe you watched this video a couple of times to really get it, but it's a bit of madness. But this is the reason why you have to do stuff like this if you're using JWT. I might do a subsequent video showing session-based authentication, which I believe is more secure. But since nowadays, for whatever reason, everybody's into JWT, that's what I'm showing in this video, and that's what I'm going to use in my app. All right, that was a ton of stuff. Let's see. All right, so the user has called into this route handler. They have, let's assume, successfully logged in. So they got their refresh token, they got their access token. So now, what can the user do? Well, okay, here it is. So in my Rust app, I have this login window. So let me just show it to you so it makes more sense. So I have this login window. I'm going to refresh this page. So for testing, I have hard-coded values. But anyway, so I have this login window. I have a particular email for the user and some password. So what I'm going to do is I'll delete this. So what I'm going to do is attempt to log in. So I logged in. Again, the cookie is not available to JavaScript. That's why this is blank. I was just making sure of that. And then the login is successful. And here's my encoded token, right? The access token I'm talking about. So then, as I said, I want to be able to make other calls that may require authentication. And therefore, I want to be able to pass the access token as a bearer token so that I can have access to whatever it is that I'm calling into, right? So I grab that access token that I received from the login, and then I pass it to my getDeveloperByEmail function. Again, a repository function that's making the fetch call to this secured URL. So I take that access token, I put it into the bearer authorization header, and then it will give me the access that I need, which means that this was successful, which is what you saw, and then the rest of my code just works, right? So what that rest of the code that is then subsequent to the login, right, doing the decoding, doing the validation looks like is what I'm going to show you now. So I have, I'm a one-man shop. So this isn't a best practices thing that I did. I'm going to eventually move this authentication checking verification code into middleware, but I just don't have time right now. So what I did is I created this authenticator, post authenticator checking function, right? That is checking, okay, did you already log in or not? That's basically what this function is checking. And then where it's checking it at is when I make authenticated calls, right? So this is a route for that get developer by email client-side function that I just showed you before, right? So this is the route handler for that call. So this call, as part of its work, it takes that email and then it gets the developer, the appropriate developer based upon the email, and then it does that authentication before continuing on to the rest of the call, because this again is an authenticated URL, right? So what is happening inside of this function then? So the function takes the username, because that's what's in the claim distinguishing the particular user. It takes the headers, because that's where that bearer token is coming in through the authorization header, which I just showed you on the client-side code. And then it takes the decoding key, because we need to decode that token and make it readable so we can verify it, right? So we have that decoding key. So then, what do I want to do? Well, first off, I just set up a variable that I'm going to use to return the result. So I just instantiated here as a temporary failure, right? Just in case the call does fail. And then ultimately I set it to success or whatever the case may be. And then I return it down here. So that's at the top, what's happening. So then I go through the headers and then I iterate on them and I for each loop on each one, right? So each individual header. And then I determine what the header name is and what the value inside of the header is. So the one that I want, the one that I care about, is the authorization header. So that's this guy right here, passed in by the client code. So I check that, and then I say, okay, you're an authorization header, so do you have a valid token for me? So I grab that and I match on it, and I say, okay, this thing does have a value for the bearer, the string, right? But let's check that it's actually valid. So what I have to do is, you can see this little space right here. So I have to split it, because I only want the token itself, right? So then I take that decode function in the initial auth service that we had inside of common, and then I take that the token itself, and then I take the decoding key, and I'm able to get my actual claims Rust typed object out of it. So then I'm able to verify, okay, are you the user that you're supposed to be, right? So I check that, and then I also check, okay, well, you can't be expired, because remember we put those super short expirations on the access token specifically to reduce the chances of hacking. So then, are you expired or not? So then we have this timestamp stuff again, right? And then if it's not, then I return okay, true, for indicating success. But if it did fail for whatever reason, then I set it to an error, and then I return, right? So then if we go back to here, if we go back to here, so we got our developer, and then we made sure that we have the actual object itself. We passed in the username, we passed in the headers from the HTTP request itself, right? And then we passed in the decode key because we need to decode it. And then we run our isAuthenticated call. And then we have to verify that. And assuming that it is successful true, right? Successful true, then I respond with the data that was desired. If it was a failure, then I pass in generic data because I don't want to leak out too much information. The client side call is aware already of what route it hit, so it really doesn't need to know that much information about what's going on in my server. Remember, the more info detail you leak about your server, the more opportunity you give to hackers. So generic error is what I'm passing. Yeah, and that's it. So I know some of this was pretty involved, so feel free to watch the video a couple of times if you need to. And then, like I said, I have some Actix Web specific videos in the channel. They're all free, as well as some of the stuff related to generics and stuff like that. So that was it. If you like the video, subscribe. In a day or two, I'll be providing the status video on SyntaxMakers, so be on the lookout for that. Otherwise, see ya.